Thank you all for being here. How many of you have been teaching for more than 20 years? Okay. 15? Okay. 10? Alright. Large number of people have been teaching for more than 10 years, right? So this is a senior faculty workshop. So there really is not much that I have to say about teaching. And now suddenly you find that there's some new word called active learning which is there. And some of you may be wondering, ye kya cheez hai? Right? I mean, we are been teaching for 10, 15, 20 years, and now what is this new thing that we are expected to learn, right? It's also perhaps a new experience or a infrequent experience for you to be sitting over there and somebody else standing here, right? And all these announcements about attendance and things like that being made, right? I mean, normally you are the one who is taking attendance, and here the roles are slightly reversed. So what I am going to do is not something very complicated or complex. It's something which many of you may be practicing in your own classrooms in informal ways, and what I will try to do is to formalize that knowledge for you, so that it becomes more effective in your own classroom, right? Okay, so this slide is typically, I use this slide for faculty who are just starting out, not faculty who have been teaching for more than 10 years, but nevertheless you can think of a good teacher that you had, or think of a colleague of yourself or whatever. So what characteristics does a good teacher have? That's the key question. So let's just have some responses. What characteristics must a good teacher have? Yeah, go ahead. Punctual, confident, polite, subject knowledge, motivator, kind, ethical, responsible, learning by doing, uses learning by doing, effective communication, able to teach different levels of students, right? Yeah. Adjustable, can adapt to the circumstances, right? Good connect with the students. Okay, yeah, so we know all these answers. So let's see. This was kind of some of the points that I got in the previous workshop. So passionate about subject, knowledgeable, good communication, right? Motivational, makes lectures interesting, compassionate, giving practice, encourages students, right? So these are all some good practices of a good teacher, right? So now what we are going to think about is that what happens to this good teacher as they go from the 20th century to the 21st century. Okay, we are all definitely 20th century learners, right? I mean, when we were studying, it was still the 20th century, maybe towards the late end of the 20th century, but still 20th century, right? So in 20th century, what happened was that the teacher used to give an excellent lecture in the class, demonstrate solving of many problems, and gave appropriate homework to her students, right? So what was the key thing in the 20th century? The key thing in the 20th century, the key point is that information was at a premium. Okay, many of us know this. So we had to travel to access library books, right? How many of you have had to catch a bus and go somewhere to access a library book, right? Many of us have had to do that. Even us, even though I studied in IIT, I still had to catch a bus and go to TIFR to access their library. Okay, so there was not easy access to information. Books were not available. So those who had access to the information and could transmit it effectively were highly valued. Okay, so that's why many of our teachers were great orators, right? Many of us are also very good lecturers, right? We know very well about how to explain a topic, how to give a lecture, right? So what were students doing in this model before we go to 21st century? What was the student's role in this model? What did we do as students? We were dependent on the teachers. You were saying something? Okay, we were dependent on the teachers, and what were we doing in the classroom? Yeah, go ahead. What was the student's role in the classroom? Was to pay attention, listen, take notes frantically, right? Many of us also develop the habit of looking up and taking notes, right? Either you or your friends. We know many people who can pay attention there and their hand will be moving independently, taking notes. All those skills we had to develop. Why? Because the information was the most important thing. And we could not afford to miss that information. We had to get all of that information. And then later, at our own time, we had time to go through that information, understand it, do the practice and all of that. Is that making sense? Yeah, this is the model that we are all familiar with. So that's what we call as a 20th century teacher model. So students were mostly passive listeners, absorbing information during the lecture and doing their practice later. Okay, so this worked very well in the 20th century. All of us have learnt in this model and many of us continue to teach in this model. To some extent it works. But what has changed in the 21st century? Okay, so before you speak out, let's do this as an activity. Whenever a slide looks a little bit blue, this is actually a blue slide. So what has changed in the 21st century that affects teaching? Think about one point and write it in your notebook or pen or paper, whatever you have. Yeah? Each one individually. So the question is, what has changed from the 20th century to the 21st century in that affects teaching? Just hold on. I will give you a chance to answer. Just write down for now. Okay. Most people seem to have written something. So let me go to the next step. So now everybody is sitting with somebody, right? So discuss the changes with your neighbor. Okay. See what answer you wrote. See what answer your neighbor wrote. And together come up with one way you can adapt to the changes as a 21st century teacher. Okay. So, having discussed with your neighbor, let's go on to talking about what can we do in order to adapt to these changes in the 21st century. Mic jara move karna. Yeah, okay. Yeah. You can speak up and I'll try to repeat what you say. If it's a short sentence, if it's a long sentence, wait for the mic. Use of gadgets has increased, so how can you adapt? Okay, so how can you adapt? So that's the question, right? What has changed? Use of gadgets has increased. How can you adapt to that? Huh? We have to be updated with the information. Okay, that's one way. Huh? Information is easily available. Okay, so what can we do as teachers? Huh? We skip giving more information and do what? We still have to engage the class for 1 hour. We have to do some illustration, yeah. We have to ensure the authenticity of the information, yes. Okay. We may have to flip the classroom. What does that mean? Okay, so we can use lecture videos and ask students to view that a priori before coming to the classroom. And then what do we do in the classroom when we say flip the classroom? We do discussions, we can do activities. Okay, we can ensure that students are able to assimilate the information. Okay, somebody else? Who had the mic? Huh.
What is teaching? Teaching is nothing. This is today is teaching is telling. Only telling is not a teaching. So we need a lot of infrastructure so that we can not tell, only telling.
Okay.
My student.
Okay.
और what is the शिक्षक? शिक्षक एक गतिहीन मोमबत्ती के समान है. जैसे कि मैंने बताया पोलाइटनेस होनी चाहिए, वो होनी चाहिए. शिक्षक एक गतिहीन मोमबत्ती के समान है जो स्वयं जलती है और दूसरों को प्रकाश देती है.
Okay. So we need to move away from only telling. Okay. Go ahead. Okay. We have to make it easy for students to assimilate and use the information easily. Distance learning has become easier, okay. Anything else? What else can you do with this? We have to make it more application based. We can show more examples, okay, we can show simulations. Instead of just imparting knowledge, we can try to extract whatever knowledge they have, make them apply that knowledge, okay. So we can do that in a flipped classroom. Many ways are there, okay. So let me move on. Let's talk about some things that the 21st century teacher can do. So these are some of the answers. So what has changed from the 20th century to the 21st century is that smart class is available. We'll just check whether you have said all these points, okay. Did somebody say smart class? Projections, yeah, somebody did. Online tutorials channels are available, yes, that was said. MOOCs, again somebody said MOOCs. Everybody knows what is a MOOC? Massive open online course. It's like any online course that you register for. When you scale it up to a large number, that's called a MOOC, massive open online course. Digital libraries, e-books are available. Virtual labs, nobody mentioned virtual labs. Did anybody write down virtual labs? Virtual classroom is different from virtual lab. Virtual classroom is similar to smart class. Okay, virtual labs is where you can actually have students do some virtual experiments. Okay, application focus has been mentioned. Teaching has become more challenging. Collaboration opportunities have increased. So, how do we adapt? So, these are some of the answers that came up in the previous session. So, we can adapt by making better presentations, whatever that means. What does that mean, better presentations? How can we improve our lecturing? How can we improve our presentations? Make it more illustrative, include examples, include visualizations, okay? We can adapt by solving real life problems. Many of you said that, right? Make it more application oriented, research oriented, get familiar with technology, give more direct application. So these are all some ways in which we can adapt as a 21st century teacher. That was one of the response which came in the last session. You have to tell me, is teaching like a business? Teaching has become more business-like. Do you agree? Yeah, it depends. I mean, not for me, but it may have happened, right? I mean, if you look at the number of coaching classes that are there, yes, so to some extent it has become like that. I'm not saying that I agree with all the points that are there. I'm saying that these are some of the points which came up in the previous session. Okay. So, in the 21st century, the main point is that information is no longer at a premium, right? This is the key takeaway for this entire session. What is active learning? Basically, the idea is that information is no longer at a premium. So the goal is not to only lecture. Lot of accessible videos, demos and other things are there. So it's not enough for a teacher to only transmit information effectively. Okay? It's necessary for a teacher to ensure that her students are able to assimilate the information through appropriate practice during the lecture itself. Okay? During the lecture itself, you want students to be able to absorb and apply the ideas that they have learnt in your class. So this is what we are calling as a shift from teacher-centric to student-centric. Okay? So till now, our focus, like for the past 20 years, those of us who have been teaching for 20 years, I have been teaching for 20 years. Okay, so till now, our focus has been how well am I lecturing? Okay, मैंने अच्छा example बनाया है क्या? उनको समझ में आएगा क्या? So these are the questions that we have been worrying about, but the focus has always been on ourselves, saying how well am I doing? What have they been doing? Students have always still been in the 20th century mode of listening, taking notes. Now that's what we want to change by saying change the focus from ourselves to what's happening in the learner. Are they actually learning? Are they learning in my class, or are they learning when they just study 1 or 2 days before the exam? When is the learning happening? So that's called shifting the focus from teacher centric to student centric pedagogy. And what we will do is we will look at a couple of techniques of how to make this happen. Okay, so let me do one more example. So consider a large class. So this classroom is actually quite familiar to me because just very recently I taught a course called CS 101. Okay, that is the basic programming course to 450 students in this class and the one beside next class here. Okay, so consider that class. Okay, you are teaching CS 101 to 450 students across various engineering disciplines. Okay, now you imagine a 90-minute class in the 20th century lecture mode. Okay, I am going on lecturing, I am giving a fantastic lecture, but I am still going on lecturing, I am just going on talking, going on talking, going on talking. Okay, and there are people over there are people over there. Okay, so the thing that you have to do is to, again this is an individual activity. Okay, you have to predict the percentage of students who may be showing engaged behavior with the content of the lecture. Okay, so if you look at the graph, so you have to draw a graph now. Okay, so on the x-axis is time. T equal to 0 is when the lecture begins and whatever t is equal to 90 is when the lecture ends. On the y-axis is your guess of how many people will be paying attention, how many people are engaged with the content. Okay, don't answer, just draw your own graph in your own paper. This is my class, it's not your class, so you don't worry about, main kya karunga. Think of it as my class. I am teaching a large class of CS 101. I am going on lecturing. See, right now I have been going on for 20 minutes. Already there is some fatigue which has set in, right? So that's what you have to think about. So what happens? What is the graph? How will the graph look? Draw the graph. Is the question clear? Okay. X-axis is time, y-axis is what is the percentage of students who are engaged, and how does that percentage vary as time progresses. Okay, don't look at me, you need to look at your own notebooks and write and draw something. It's going to be fun because the next step will be interesting. So just take the minute out to draw the graph. No, don't answer. You draw the graph, whatever may be the assumption, you draw the graph that you think will be there, will happen. Draw some points, yeah. Just the shape of the graph, yeah, that's fine. Yeah. Just the shape of the graph is fine. I don't need to see points and, yeah, that's fine. Yeah. So some people are actually trying to plot points. That's not required. Just the shape of the graph is sufficient. Okay, how about here? Alright, good. Okay, having drawn the graph, now let's go to the next question. Okay, everybody has drawn the graph? Kaise dikhta hai graph? Starts like that and eventually dies off. Okay, exponential decay, somebody is saying, right? Okay, that's again another good graph. It starts, it decays, suddenly there is a spike, and then again it goes off, okay, or it's a graph like this, it's some kind of a bell-shaped curve. So pretty much it starts high and slowly peters off, then the instructor does something, panics, and then again it goes up for a little while and again it peters off. Essentially that's how the graph of any large class is going to look, okay. So this is pretty much how it will look, some variant of this one, okay. So now here's an important question for you, pay attention. Okay, so now you look at your neighbor's graph, you can compare कि आपने ऐसा क्यों किया, मैंने ऐसा क्यों किया, and then come up with one technique, not two techniques, come up with one technique that can make the graph look like what I have drawn, okay, where the engagement is more or less sustained, even in a large class, okay. So you can, if three of you are together, three of you can talk. So look at each other's graphs. मेरा वाला ग्राफ ऐसा है, आपका ग्राफ कैसा है? Okay. Yeah. So what do you do to make the graph look like that? What will you do as an instructor? You have been teaching for how many years? Yeah. So we'll take all the answers. Come up with a list and make a list and keep. Okay, that's the amount of activity that happens in my class. Okay. Okay, what can be done? Some answers. Let's start from this side. So if the answer that you have is already there on the board, then don't repeat the answer. Yeah, okay, we'll start. Yeah. Give some task or activity. Okay, next. Short videos. Okay, show short videos. Okay. What happens if I show short videos? Okay, we'll come to that. Huh? Okay, real life problems of real life problems. Okay, then what else? Interactive. That's a very loaded word. Huh? Interactive. I'm going to put it in quotes because interactive can be in many ways. Asking questions. Huh? Asking questions randomly. Roll number 13. Give me the answer to this question. Right? Next time क्या होगा? Roll number 13 आएगा ही नहीं class में. Right? What else? Competition of question answers. Okay. Competition of question answers. So debate basically. Some kind of a debate. What else? Somebody from here. Give a case study. Okay. Discuss a case study. Okay. Discuss a case study. What else? Saying some jokes. Yeah, I was waiting for that one. Okay. Saying a joke. Okay, what happens when you say a joke? Some attention comes up, right? Huh? Storytelling, okay, telling some story, saying a joke, storytelling, taking attendance. Taking attendance, okay, yeah, people are at least listening. Mera naam kab aayega? Okay. Real life examples connected with theory. Okay, connected with the theory. Okay, quiz on the previous class. Okay, so we say we'll start with a quiz. So if I say that next class mein quiz hone wala hai, on this class, everybody is going to pay attention, right? Okay, that's one way. Yeah, anything else? Huh? Wearing the pitch, yeah, suddenly I scream, right? Wearing the pitch. So suddenly I scream and then people feel कि okay क्या हो गया इसको, and they are all looking at me. Yeah, so now we'll come to evaluating these strategies. Okay, is that more or less captured? Everybody's ideas are on the board. Sharing own experience. Okay. Okay, fine. We have some 12 ideas on the board. Bonus marks. Okay, fine. Let me write that also. Okay. Discuss current affairs. Okay, I'm going to put it along with case study, current affairs. Okay. Okay, that's like, okay, आज कौन सा कल कौन सा movie release हुआ? Okay, current affairs. Right? That also is a valid way. So now, okay, so now that we have a list of techniques, let us see. So the question, what was the question? Let's go back to the question. The question is, we want most of the class to be engaged most of the time. Okay, so we are saying 80% of the class is engaged for 80% of the time. Sustained engagement, that's the challenge. Okay, now let's see whether these techniques meet that challenge. Okay, give some task or activity. Will that sustain the engagement? Will that engage most of the class? Yes, provided task has to be interesting, it has to be structured. Okay, how many of you are sleeping now? Right? Nobody, right? Nobody is going to say I'm sleeping. Okay, how many of your neighbors are sleeping now? Right? Again, nobody, right? Why is it not possible to sleep in this class? Huh? फर्स्ट लेक्चर नहीं, फर्स्ट लेक्चर में तो नींद आता है, लंच के बाद तो ज्यादा नींद आता है, ठीक है. So not just because of the first lecture, because the way the activity is structured. Okay, you are not talking to me, you are talking to your neighbor. So if you are sleeping, your neighbor is going to wake you up and say, बताओ तुम्हारा ग्राफ कैसा दिख रहा है. Okay, so that's the important point. Second one, let's see, showing of videos, will that engage the entire class? Huh? Yes, no? Yes? Will that engage? The answer is yes. Will that engage the entire class? वो पीछे बैठे हुए जो कुछ तो डिस्कस कर रहे हैं अपने आप, they are not going to look at your video. Okay, may or may not engage the entire class. Okay, asking questions randomly, we again saw, if you ask questions randomly, some people will be active, but the stress level in the class is going to increase. Everybody will be active, everybody will pay attention. Yes, so the next turn may be mine, so I will pay attention, but in the next class I may not come, right, because that's too much pressure, putting me on the spot, right. Saying a joke, what happens when I say a joke? Momentarily the engagement goes up, after some time focus shifts, after some time it's back to normal, right. So many of these activities, while they are good ways, they are effective only for momentary increase in engagement. They cannot sustain the engagement, one. Second, they cannot sustain the engagement with the content, right. So suppose you are talking about current affairs, yes, you will engage the audience, but are you engaging them on the topic that you are supposed to teach? That is the next question that you have to think about, right. So the key point that we are trying to discuss in today's session is to see how to engage the entire class. So here are some answers that came from the previous session. Okay, have small activities, you said, ask examples, you said, demos, you said, videos, you said, telling jokes, you said, ask them to stand up and clap. Okay, that's something, allow students to move around, giving small breaks, playing games, personal interest, all these things you said. Keep blue slides in the PPT. What are these blue slides? The ones that I have been using, where you are supposed to do something, right? That's the key idea. Blue slide means I am resting and you are working. The white slide means I am working and you are listening, maybe. Okay? So discuss previous homework, group activities, include puzzles. I think most of these points you have mentioned. So that's one answer somebody gave. It's just like I noted down all your answers, I noted down all the answers from the previous session. Okay? How can it help? It can help. It depends upon the size of the class. It doesn't, I'm not saying that these are the actual ways to do it in a large scale. These are some answers that came up. Okay. Okay, so how to do this learner-centric pedagogy? So one way to do this is what we call as active learning techniques. Okay, what are active learning techniques? You have already experienced two such techniques. Yesterday you experienced the technique called peer instruction. Right? You wrote multiple choice questions, you had discussion. Happened yesterday? Okay, so that's called peer instruction, and today you already experienced one active learning technique called think pair share. Slide में लिखा हुआ था ना, right? Nobody thought of asking me ये क्या चीज है think pair share. See, on 3 slides it's say, the slide title is saying think pair share. So what happens in a think pair share? Can you tell me now? First, you think individually, then you work with pairs, and then you share the answers with the class. Very simple technique, but very effective for keeping engagement in a large class. Okay, so the key idea is that students need to go beyond listening, writing notes, executing prescribed procedures. Students are asked to figure things out for themselves, and it needs an attitude shift from being content oriented to learning oriented. And how well am I teaching to how well are they learning? Okay, so these are all fairly standard, straightforward things. So let me just quickly show you some evidence. So what this means, so I just put the entire slide, it's a little busy slide, but I'll explain it a little bit. So now we've been talking about these active learning techniques, peer instruction, think, pair, share and all. And many people ask the question, are they really effective? Is it really useful? So that's why there was a study of 62 physics courses done, across 6,000 students and across a large number of universities. Essentially the idea was that the 12th standard physics and the first year physics curriculum is more or less the same, right? So they did a pre-post test. They did a test after 12th standard to see how much physics does this, do these students know, and they did a test after the first year again to test how much physics do the first year, at the end of first year, do students know. And in different colleges, different instructors use different styles. Okay. So if you look at the graph, the red ones are the teachers who did very good lecturing. Okay. And what is plotted on the x-axis is what's called gain. Gain, basically you can think of gain as a measure of how much learning has happened, how much knowledge has the student gained. Okay. So what they found in this study was that however well you lecture, so if you look at the red one, so however well you lecture, however good your class may be, the gain for the students is not more than 0.28, okay, 0.28, 0.3. So essentially it's only 30% learning is happening over and above what they know if you are lecturing, okay. So many of these lecturers, they were not bad lecturers, okay, they were very good lecturers. Many of them had won best teaching awards and things like that. They were excellent lecturers, but still not much learning was happening. Why not? Possibly because students were just listening. Students didn't have to do anything on their own. On the other hand, if you look at the green one, the gain started from 0.2 and went all the way up to 0.7. So any teacher who is using active learning techniques, including new teachers, okay, who have been in the system for only 1 or 2 years, if they were using active learning techniques, suddenly they found that in their class, a lot of learning is happening, irrespective of how good the lecturing is. So that was the basic evidence for saying that we must incorporate these active learning techniques in our classes, okay. None of these are new techniques, okay. This technique, think, pair, share technique, was invented in 1980, okay. It's 1980, 1990, that's since then people have been using it. We are just coming to know of it now. Many of us have used it in an informal manner, right? In your class you have asked students to work things out. You have asked them to do group discussion. It's not that हमको कुछ पता नहीं है, पता है हमको. All that is important is to make it formal, because when you make it formal, it is effective for the entire class. Okay, that's the only additional point that I am making here. It's not like, how many years have you been teaching? 15 years you have been teaching. What is there for me to teach you about teaching? There's not much left. I just have to add a little bit small things. So don't worry about whether I am giving you notes or whether I am not giving you notes. That's not important. If you get that one idea and you are able to implement it in your classroom, we are done. Okay, so now let's look at this question. Many teachers say, I often pause to ask students if they understood the material, right? How many of us do that? Sab log karte hain, right? We all do that. I allow students to interrupt whenever they have doubts. Is there anybody here who says that you must not interrupt me till the end of my class? Right? Nobody says that. All of us do that. I never hesitate to answer their questions. I often show them demos and videos. I try hard to find new material. Okay, this is true of all of us. So people say that, okay, my lectures are very interactive. Isn't this active learning? Yes or no? Yes, how many people think yes? Few, okay, no? Fewer people think no. What about the rest? Maybe? Yeah? Maybe? Okay, see, we have to go back to the definition of active learning. Definition of active learning is most of the students are engaged with the content. So now let's examine these techniques. While these are all good techniques, okay, now think of this class. I mean, we are having how many people, how many of you are there? 300 of you are there in the class, right? So I have to have techniques which will engage those two guys over there and these two guys over here at the same time. I can't only be focusing on the first row. So that's the key point. So why these interactive lectures may not be enough? While they are necessary, they are not enough because students don't pay utmost attention throughout the lecture, right? Who is the most excited person in this classroom right now? It's me, right? Do you know how many times I have done this session? At least 30 times I must have done the same session for different audiences. The 31st time I am still as excited. Why? Because new audience is there, okay, people have come from far away, they must get at least this idea, इनको तो समझना ही है. All those things the excitement is there in me. Okay, कोई सोच रहा है अरे आज ब्रेकफास्ट थोड़ा ज़्यादा खा लिया है, right? कोई और सोच रहा है कल रात को नींद ठीक से नहीं हुआ. Okay, so all those things are happening in people's minds which I am not aware of. I am thinking because I am excited, you are excited, right? So that is the key problem. Whenever we are focusing on ourselves as lecturers, the problem is students are not always paying attention, however good you may be. The second point is that students think that they understand because they can follow the lecture. Okay, a lot of us do that, right? We do very neat derivations, we explain things very nicely. And so when students are looking at the movie, they feel that okay, they are able to understand everything. And when do they find out that they haven't really understood? Exam mein. In the exam. When do you find out that they haven't understood? Again while checking the paper. And then you're shocked. You're saying, okay, मैंने तो इतना अच्छा सिखाया था. वो लोग भी सब नॉड कर रहे थे. लेकिन ऐसे मार्क्स आए हैं. होता है ना? So that is the whole point. So the second problem with those interactive techniques is that it's difficult to ensure that all the students in the class participate actively. Okay. So if we are doing that interactive lecture, students with high motivation, okay, often students in the first few benches, they'll drive it, they'll keep asking questions, they'll keep interacting with the instructor. And what happens to us as instructors? We think that entire class is following. Okay. We have no idea what's going on in the back benches, right? We don't know whether they are on their phones or they are looking here or they are looking there. I am looking at all of you. But we think that okay, sabko samajh mein aa raha hai. That is one problem. So students with low achievement levels or no motivation levels get left behind. And then the third point is that if you ask students randomly, okay, students may have a barrier to responding to the instructor. Okay, shy students don't ask questions, we all know this, right? Or give answers. And forcing all the students tends to be counterproductive. Next class they may come, they may not come. Essentially it increases the stress. So what we want are very gentle techniques. Okay, so I'll skip this slide. So what we want are some active learning techniques like think, pair, share that we have seen now. Okay, that was invented in 80s, or peer instruction that we saw yesterday, that was invented in the 90s. These are some active learning techniques that are useful both in small class as well as a large class. Okay. So the key point is to learn the technique systematically and use it in your classroom. Okay, some gentleman over there said, ये सब IIT में चलता होगा, हमारे college में नहीं चलेगा. Right? Is that true? Why? आपके college में क्या problem हुआ है? Yeah, go ahead. No, so let him speak, yeah. Okay. Okay. That is okay. So that point is well taken. So the point here that he is making is that students, if they are being evaluated, if the paper is being set by somebody else, and I have put in a lot of effort to make sure my students understand, but paper may, if there are only recall level questions, write short note on type of questions, right, then there is no use. Students are only going to do that. That's a very good point. That point is well taken. For that we need control on the exam. But nevertheless, what is useful is, since anyway the students are there in front of you, they might as well learn something about how to apply the concepts, okay, and it may be useful to them elsewhere. So the only point about these techniques is that they help students grapple with the content and assimilate the content. Peer instruction is what you experienced yesterday. Okay, let me do one more example. Let me do one example of peer instruction. I think you might have seen it yesterday. So this one, peer instruction. Did you see this example yesterday? The same example? No, no. Okay, so let's do this example quickly. Peer instruction ka example. A large piece of ice is floating in water in a bucket. When it melts, what will happen to the water level in the bucket? Don't answer. Just hold up your answer like this. 1, 2 or 3. Each of you. Everybody has experienced this, right? Kya hoga? Yeah, don't hold it up high also. Just so that I can see. How about you guys? Not yet voted. Everybody has to pick one answer. Pick one. Don't talk yet. You just choose your answer. Okay, has everybody picked an answer? How about you guys at the back? Don't tell it out. Just show me. Okay. Alright. So, this is the first step of peer instruction. You pose a question like this. You ask all the students to choose an answer. The second step is discuss with your neighbor and check whether your neighbor has the same answer. Just check whether your neighbor had the same answer. How many people say it will rise? Some number of people. You have to convince your neighbor, right? I mean, I need to see groups of people saying the same thing. How many people say it will fall? Okay, some people are saying it will fall. How many people say it will stay the same? Okay, and there are still some people who are not voting, right? Even after all this. So in your class, you can make it actually, because you know your students better. You can ensure that everybody votes. So now after you do this, you want to actually do the discussion. Why do you think it will rise? So whoever says it will rise has to argue that it will rise because. Somebody here, right? Rise because? Because volume of the water is increasing. So, okay, it will fall because somebody said it will fall. If you consider the mass of the air which is trapped in the thing. So this is actually an ideal thing to bring out misconceptions. Are we in a physics class? No, right? So this is which level physics? 8th standard, 9th standard physics, right? So this is a good way of bringing out the differences. Like for example, what it says is that the piece of ice is floating in water in a bucket. If you put the piece of ice into the bucket, it will rise, okay. But it is already there inside the bucket. Second point is that, I mean, it is not saying that, but the ice and the water are made of the same water. Okay, so if the ice is made of different water from the water, like it's sea water and and floating in fresh water, then the answer will change. So a lot of such intricate things. So even though it appears to be a very simple question, you can use it to bring out a lot of deep concepts associated with the topic. Okay, so in this case it doesn't really matter what the answer is for us. The whole point is that a simple MCQ like this, where the key idea is to make students vote, make them discuss and make them vote again. That ensures that a lot of learning happens, one, and secondly, it can engage the entire class. Okay, were you all discussing about this or on something else? Over there at the back, right hand side. Were you talking about this or something else? About the topic, right? So it doesn't matter how large your class is. Everybody is going to be engaged on the same topic. So that is the power of these techniques, peer instruction or so peer instruction, the basic idea is very simple. We are all used to writing multiple choice questions, right? We usually give the multiple choice question in the exam, correct? So what we are saying is take the multiple choice question out of the exam and put it into the classroom. So ask a question, make students vote individually, okay, make students vote individually, let there be some peer discussion and then you have a class discussion and then go into the lecture. Very simple technique, but very effective technique for engaging the entire classroom. Okay. Second technique was think, pair, share that we just saw. Okay. So I'll go back to the think, pair, share. So team, pair, solo is another technique which is useful when you want to break down a large problem. Okay. So when you want students to attempt a large problem which is very daunting for them, like for example if you say okay, large software design problem, or if you say okay, design a system which will ensure that messages are transmitted from one sender to a receiver across a network, where students are not familiar with the topic, they're using a technique called team, pair, solo, where first they discuss in a group and then they come into smaller groups, is very effective. Okay, so we won't be talking about team, pair, solo, but we talked about think, pair, share and peer instruction. Okay, so what happens in think, pair, share? We already illustrated it through the example. Why use TPS is that well-known challenges in large classes can be addressed, and it's a relatively easy way of achieving the benefits of small group cooperative learning in a large class. Okay, I mean, I can't stress this enough. Like if you look at this class, there are 300 people in the class and the technique is effective to keep 300 people engaged at the same time. So that's the power of such techniques. Okay, so all these slides are available on my web page, so I'm not going to read out the definition and so on. So essentially what happens is, first you make the student think individually, then they work in pairs, and finally they share their answers with the entire class. Okay, so let me just put up all these 3 points. So teacher asks a specific question and students have to think and write their own answer. Okay, you had 2 things in which to do think, pair, share already. One was the graph and the other was what changes in the 21st century, from 20th century to 21st century. So any topic you can take and you can create a think, pair, share activity out of that, and it will ensure that the entire class is engaged. Okay, one reason why it works very well is because you are expressing your idea, right? When you think and you write, you are writing your answer. It's not like you are listening to my answer and you are noting down my answer. So it's your own answer that you are writing. And because you are writing your own answer, there is some investment in discussing it with your neighbor, and there is some investment in ensuring or in understanding why that answer works, does not work, and so on. Okay. So in the pair phase, teacher asks another question related to the previous one, and they share their thinking with each other and proceed with the task. And in the share phase, students share their thinking with the entire class. Okay, it has many benefits. I'll just list down a few. Okay, so it works because students are actively engaged. Were you all engaged? It's been more than an hour into the class. Okay, students learn from each other. Is that happening? Students can tackle large, ill-structured problems. Okay, other benefits are that it makes the class interactive. People realize that others are also struggling. This is a very important point, right? Often students in our classes, they don't ask questions because they feel सिर्फ मुझे नहीं आता है. But when they realize that okay, मैंने 2 बोला था, उसने भी 2 बोला है, ठीक है, maybe it's okay that I'm not the only dumb guy in this class. Okay, the moment you realize that, it's fine. You feel a little bit of a motivation goes up. Okay, so it builds a friendly yet academic atmosphere, and most importantly, it includes all the students in the teaching learning process. Okay. Yeah. Okay. Okay. So the question is that okay, I am teaching a topic like fast Fourier transforms. So I don't teach fast Fourier transforms, but I teach computer science. I teach sorting algorithms, for example, this one, and several. Okay. Yes. Can I take over now? Okay. You are finished with the question, right? I'll take over. Huh? So now the point is, the first answer is yes, that this has been tried in India. We have done it in large number of colleges. I use it in my class all the time. Many of my colleagues use it. We have even written papers about it. Okay, so this 80% engagement. So if you go to my website, you will find that my students have actually sat in this class. When I was teaching CS 101, my education technology PhD students have actually sat in this class and done observations, saying, okay, how many people are on task, how many people are playing with their mobiles and things like that, and they've come up with numbers to say that, okay, look, it does work for 80% of the class for 80% of the time. That is the first point. Second point is, does it work for technical subjects? The answer is yes. Okay. It depends upon how well you are able to construct the question. Okay, now I cannot talk about fast Fourier transforms, but what I can talk about is sorting algorithms. Okay, so typically it's a similar topic. So sorting algorithms typically takes 3 to 4 lectures. Okay, because you start with selection sort, then you go on to quick sort, then you go on to merge sort. Okay, how many people are CS faculty here? Okay, there are enough people are there. Okay, so you explain one topic after another, one sorting algorithm after another, then you do the derivation of their order of complexity, all that is familiar, right? So what I did in CS 101, which actually does not include the topic of sorting. Sorting actually comes in data structures, the next course. CS 101 is not really the one. What I said was, okay, consider an unsorted array of n elements. If you look at the example. So the think phase only says, write the pseudocode for sorting the array. Everybody knows how to sort. Okay, it doesn't matter whether you're a computer science student or any other student. Everybody has their own idea of how they are going to sort the numbers. That's what the student writes down. Okay, in the think phase. In the pair phase, once you have some algorithm and you have some other algorithm, in the pair phase, it says that, okay, discuss your answer with your neighbor and do the pros and cons analysis of your algorithm. Okay, so some people say, okay, my algorithm, whatever algorithm that I have come up with, will work very well if the numbers are already sorted from ascending to descending, or if the numbers are jumbled in this manner, or if this is the range of the numbers, and so on and so forth. Okay, so that is the second thing that happens in the pair phase. So in the share phase, what I did was, I said, okay, let's hear some answers in the classroom. Okay, so what happens is, somebody here will say that, okay, I am going to do the sorting in this manner. So all I did, it was this very same board that had to be used. It was in this very classroom. So all I said was, okay, this is one idea which somebody has put up, okay, which was to say that I am going to take every element, find its place in the array and put it in its correct place. Okay, so that was one idea. And I said, okay, all those who have similar ideas need not speak up. Is there anybody who has a different idea? Then somebody else says that, okay, I am going to look at I am going to first find the highest element in the array and I am going to put it at the end. Then I am going to find the second highest element. So that way, what happened in the class was, in a 1.5 hour class, all these sorting algorithms were actually reinvented by the students. Not in their complete detail. Okay, they won't be able to talk about the order of complexity of that algorithm, but they had got the basic concept of all these algorithms. So something that would have taken me 3 lectures actually took 1 lecture. Okay, so this kind of thing, however much I tell you कि ऐसा होता है, you won't be convinced. Yeah, sure. So it will change only if you try it. No. Go ahead. Okay, go ahead.
The thing is, these techniques are basically taught to management. Right? So let me talk to you.
Go ahead.
When you are giving this course for technical teachers, very specific and take examples from technical education subjects.
Yes.
That would be more useful for the teachers. When you are talking about sorted algorithm, how will you sort the numbers? How will you sort the numbers? Students are coming up with useful ideas that I know a person checking technical is more about. They will be able to do that. The person who will be able to sort algorithm, research behind it, and he came up with this idea. Not in 15 minutes, you cannot come to that idea.
Yeah, go ahead. No, so, okay, so maybe we'll discuss afterwards, but the key point is, I'm not saying that the student is going to invent the entire algorithm at the same time, immediately, okay. What I'm saying is that the basic concepts can be taught to students. This is not something which only management people use, okay. I have used it in CS 101 extensively. I teach 2 courses, programming and networks. In both the courses, I have used them extensively. Even Professor Gadre has used it in his signals and systems courses. So here is another example. where when we are talking about designing software, again how you can use think, pair, share to design software. Okay. And there is one activity that we can look at on our departmental website. Let me just show you the departmental website. So if you go to our department website, there, and if you look at resources, teaching resources, you will find these resources, all these lectures and slides that I have been using, they are available here. So we have created resources which actually help you to plan your TPS activities. So, and if you look at the end of it, there are examples from technical topics. It's not just examples from some, like as you mentioned, it's not just a management type of a topic. There are a lot of technical topics for which we have been able to write these examples and make students do. Okay. So I won't ask you to write these questions. I'll just do one more activity and then we'll stop. Okay, even though we are a little ahead of time. So we have looked at this peer instruction technique. So what we have done is we have looked at peer instruction as one technique. We have looked at think, pair, share as another technique. Okay. So now the third thing that I want to talk about is how to use visualizations in your class. Okay. So normally what do we do? Visualization. Suppose you are showing a demo. What do we do normally? We show a demo in the class, right? So here is a demo. This probably did not play yesterday. It was shown. The video didn't play. Okay, so let me play. So did you guys do the activity of deciding what's going to happen? What's going to happen? Is it going to go front or back? Stationary? Okay, shall I play it? Okay, today it'll probably play. So if you look at it, so where did it go? Was your answer correct? No? Okay, look at it again. Okay, so when you push the trolley, the balloon actually goes ahead. So again, the point is not the physics part of it right now. What I want to illustrate is the power of flipping the showing. So normally what we would have done is we would have simply shown this video in the class and we would have had a running commentary along with it. We would have said, देखो अभी ये आगे जा रहा है, and so on and so forth, right? So that would have been our normal way of teaching this topic. Instead, if we pause the video, ask a question, make students think, make students vote, and then continue with the video, it has been shown to be very effective. So this is all that I am saying. Just take your multiple choice question out of your exam, put it in your class. Instead of simply showing a video, pause the video and ask students a question about it, make them think. And the third one is, instead of simply explaining something, create a think, pair, share activity by which students can come up with at least the basic ideas of that on their own. Okay. So I think that's about all I have to say. I mean, I was going to actually make you write a think, pair, share question, but it doesn't appear that many of you are in the mood to write a question right now. So we'll stop here.